condensing into clouds, the atmosphere itself, the carbon dioxide of the atmosphere itself, makes its own clouds and prevents it from getting any warmer. And so there's been other ideas and maybe adding other greenhouse gases, but that's the issue. So it's not that people don't believe in the lakes or the oceans or things like that. It's that uh, some people just think we really have tried our best with these climate models and we can't figure it out. So perhaps that's telling us that Mars never was warm. Now, how would they explain the lakes? Well, even in a relatively cold Mars, where you're right around the freezing temperature, perhaps, you would have areas that are very icy. It's sort of like Antarctica. But underneath that ice cover, you might have a liquid water lake that's sort of insulated by the ice above it. And you can create lakes that way. You can even create mud gathering at the bottom of those lakes because you might have a stream underneath the ice. But everything is very slow in those very cold environments. Erosion is very slow, evaporation and precipitation are very slow. And so that's where I still feel like in that kind of icy environment, how do you form, a quarter mile thick of those deposits and create all that erosion to supply all that mud into Gale Crater? So sorry for the long answer, but it's a big mystery.
Yeah, that's a great answer. I appreciate that. Our next question is also about water. How does water just form on a planet? Is it random chemistry?
Yeah, it can happen different ways. There was water in the initial solar system when all the planets were forming. And so Jupiter, for example, has a lot of water in its atmosphere just from that way it originally formed. Earth and Mars, we think, had that water, but then the sun was very active, and Earth and Mars both lost a lot of that initial water. But then it was resupplied, for example, by comets that were still a lot more popular populous back then. Comets were flying around and hitting Earth and Mars, and enough comets could hit those planets to actually supply them with a lot of water that was then retained and not lost again. So it's ways like that, and water also comes out through volcanoes and can then be part of the environment.
Okay, very good. Next question is about life. As Earth's glaciers are receding, we are finding bacterial life. Do you expect that as a possibility on Mars, at the poles, or anywhere else?
Yeah, it's interesting. If you were to have any, well, um, there are a lot of people who think that if we could just do whatever we wanted, and money and technology were not an object for Mars, the best place to look for life would probably be underground, because we know that Mars um, had, 3 billion years ago might have had a nice atmosphere and a little bit more protection from the ultraviolet light of the sun and all those things. And today, the surface environment is actually pretty harsh for life. So if you're going to try to look for things that are alive today, maybe you'd want to dig underground because maybe there's still liquid water underground. You're protected from that harsh surface environment. So I think that's kind of along the lines of what you're saying. If there are places that are naturally being exposed that were once underground to being now at the ground level because ice has receded, or maybe a landslide's happened, or an impact crater plows the surface, maybe that's a cool place to look.
All right, very good. Next question is looking toward the future. What are the plans for the Artemis mission to use data from the Curiosity or Perseverance rovers?
Yeah, I can speak to a couple of things. I think a lot of those plans are still being worked out exactly how they'll use or what they'll do at Mars, because a lot of the focus is on the moon right now, of course. But both Curiosity and Perseverance have parts of the mission that are actually flown on behalf of the human space program of NASA. And so Curiosity has an instrument called RAD, the Radiation Assessment Detector, which measures radiation at the surface of Mars, which we've never done before. So we know that radiation in space can be harmful to astronauts, so you have to protect them from that radiation. And so we've measured it. We measure it in the space station. We measure it all the time with satellites. But on the surface of Mars, Mars' atmosphere is thin. That radiation still gets in, and it actually gets changed by the atmosphere in some ways for good, in some ways for bad. So measuring radiation from the surface of Mars is really important to help